Okay, in that video, I missed a lot, like a lot. Okay, I'm gonna have to like speedrun that while this video is being uploaded. New space, quickly. Okay, basically, Sigma, funky. Ah, ah, please, I beg. Okay, ignore this. In fact, okay, you can still see it. Doesn't matter. Sigma, funky Greek letter. Um, the notation will usually be r equals 1 to the n of some function. This looks shockingly like an integral as it works almost the exact same way. Why does that look like an S? Okay, integral you have b, a, k representing some constant that you might multiply by your function x, and you have differences. To be honest, that aren't really. Sigma is discrete, um, basically meaning it only works with natural numbers. So n, or r in this case, I should say, r is a member of the positive integers. Actually, can flex of the natural numbers. Okay. While integration just works with well, almost anything to work with. Okay. I think. Don't worry about that. Okay. Anyways, integration is a little discrete. So let's say you had a graph. Summation would be more like, oh, find the area approximately using bars. Whereas integration is not discrete, so it can just do whatever it wants. Anyways, that's not really important. What is important, I forgot to mention how anything actually works because I didn't. Anyways, n, your final number in the series. So let's say you had 1 plus 2 plus 3 plus 4 plus 5 plus 6, 7. Okay, that works. Usually you would do 1 plus 6 is 7. The way you could sum up a series really quickly, if you count how many terms there are, excluding the middle term, this is that there is no middle term, so it's perfect. 1 plus 6 is 7, 2 plus 5 is 7, 3 plus 4 is 7. So it's just a really cool technique. So it'd be 21. For another sequence, let's say this 7 plus 8 plus 9, 10, 11. It's more likely what you're going to get. 12, 12, 12, 12, 12. 5 plus 6 is 11. No, this, I've made a mistake. This, okay. When did that happen? Okay. We have 1 plus 11 is 12, 2 plus 10 is 12, 3 plus 9 is 12, 4 plus 8 is 12, 5 plus 7 is 12, and you have 6 on its own. 6 is the middle term, so you just you just add on 6. That's just the other way of working stuff out, which is by hand. So without a calculator, so you would count how many terms there should be. So you divide your thing into 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but you don't need to worry about that. So you could do 5 times the number of, okay, 5 times the sum of this, essentially. So 5 times 12 plus 6, which is where, I just do this, 66. I already know it's correct because if you do 2a, wasn't it 1 over 2a n minus 1? You'll recognize this formula from A plus N minus 1D, which you possibly used in GCSE somewhere. Anyways, those don't matter anymore. You still use them, but blah, 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 blah. Sequence. So sigma, if we go back to our summation over here, N, final number in the sequence, is 11. And initial number is 1. So R equals 1. We want to start from 1, goes to N. So in this case, let me just replace it with 11. I know I'm going quickly, but I'll slow down. Our function is just n. Like that's the nth. That's the formula for the sequence. It's just n because n 2, 3, 4, 5. that doesn't really matter. But we can't use n because n was being used up here. So instead we put r. If you're wondering why, r just goes up by 1 each time because you're calculating the sum of this. 1 is just 1, 2 is just 2, 2, don't worry, it will make sense. The next one, so this would just be n. There's nothing here because it is literally just n. That is the sequence. So we can cross this off. There we go. We've written it in sigma, or wrote it in sigma notation. Next, the formula for anything linear, such that, let's say this was to the exponent p, such that p equals 1. The formula for this would be 1 over 2 n, that looks like a u, n plus 1. Okay. 1 over 2 n plus 1. You just substitute in 11, which was your n, and you get the sum. So if we do it now, 1 over 2 times 11 times 11 plus 1 is 12, is equal to 1 over 2 times 132, which is equal to 66, which is exactly what we got up here. So it works. We just substitute into a formula. If you want to do it manually, like you want to understand why this formula works, we can do it. So basically what we're doing, we're saying for every value of r from 1 to 11, we substitute into whatever was here. So this was k, multiply the function is just n, so it's just 1 plus the next term, which would be 2. So when r equals 2, is 2 plus 3 plus 4 plus 11. We stop at 11. If we do something a bit more complicated, which it isn't, but it looks more complicated, so let's say it was 5, r equals 1, 2, 3, r, so r just being the one we replace, and 5 being our limit, this would be, you do the formula, it would just be, we can move this over here, by the way. Same with integration, you can just move constants outside that are multiplied by everything. So this could go here, so you don't have to deal with it for now, and just multiply it at the end. And 1 over 2 n 5 times 5 times 5 plus 1 is 6, 6. So 30 over, well, we can get rid of it, 3 over 2, 1545. Bless me. 45 is our answer. If you want to do it manually, you do it with 3. In fact, I'll do it in the summation. 5, 1, r, nope, it was 3r. What we're actually doing is, we're doing 3 times 1, which is our starting term, plus 3 times 2, which is our next term, plus 3 times 3, which is our next term, plus 3 times blah, 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 blah. So we get to 3 times n. N was this, which is our final term. Next, doesn't really get more difficult than that, to be honest, with generic summations. Why can't I zoom? I think you might have slightly more difficult stuff with n squared and n cubes. That's probably fine. They don't really change. If we have n r equals 1 or r squared, this looks more difficult. Bear in mind this, you cannot just do n r equals 1 to r blah blah blah. I explained this before. This is no, that's not no. If you test it, let's say we had a sequence of 1 to 5, so 1, 2, 3, 4, 5. If we wanted to sum it, we try this one. If we input it, would be when r equals 1, it's 1 squared plus r equals 2, you go up by 1, 2 squared plus 3 squared plus 4 squared plus 5 squared. You test it for this one, which is just squaring the whole thing. 1 plus 2 plus 3 plus 4 plus 5 squared. This, I believe, is equal to this one is 15 squared, 225. This one, it's below 100, I think. Yeah, it's 55. Okay. Okay. These obviously not the same, so it doesn't work. Besides the point, when r is squared, or you have an r squared, the corresponding summation formula will always be 1 over 6 n plus 1 2n plus 1. When r is cubed, the corresponding formula will be 1 over 4 n squared n plus 1. You just need to memorize the formulas. So let's say you had something like r equals 1 for 3r squared 2 5. Firstly, you know that you can move this over to here. We could technically rewrite this as 3r squared. Then we plug it into the formula, which would imply that we have 1 over 6 times 5. Then we have 5 plus 1. There we go. Then we have 2 times 5. At a point, you're going to stop using the square brackets because there's not really a point. You have too many layers. This would be equal to 3 times. So that's just 1 over 2, but actually I'll do it immediately. 1 over 2 times 5 times 6 times 11. So that's 66 times 5. Okay, that's 30 times 11. That's 15 times 11 is equal to 165. There we go. Summa sequence found using sigma. Next, you need to know how to split them. Splitting them is easy. Same with, in fact, it's just the same with integration differentiation. Like if you have f of x plus g of x dx with respect to x dA, exactly the same as f. I should probably get rid of this before I do something stupid. Then you just add them. Same works with summations. So if we had 3r1, take that, r squared, same as 3r plus of squared, cut in half. Okay. Splitting them, multiplying, nothing really else. Oh, let's say r equals 2. So let's say we have a sequence 1 plus 2 plus 3 plus 4 plus 6, blah, 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 plus 12. And we don't want to start at 1. We only want the sum from 3 all the way to 12. R would start at 3. And then it would end at 12. If we don't want to start end at 12, we can end at whatever we want over here. But we're doing 12. Obviously, you would just put this into the formula, sort of. On a calculator, you can do this directly. So this is just n, like in a nth term, blah blah blah. This would be n, so this would be r. You will be told like what goes here usually as well. Don't worry about that. But yeah, this is r. So yeah, you could plug this straight into your calculator and you get an answer. Or you use the formula. The formula method is what they usually go for because they'll give you algebra and stuff. So the way summations work, you usually start with 1 because that's just how it is. So we're doing 3, well, we're skipping these 2 terms. If you could see it visually, you're literally just doing the whole sequence, take away this portion, which is what we're going to do, because you can't put this in the formula, because the formula obviously starts from 1 to 12. So this is identical, no, it actually is identical this time, to 12 equals 1, take away 1 to 3, or 1 to 2. To 2. So if you're wondering, we're doing the whole sequence, take away this small portion to give us this larger portion, which we were asking for. So from 3 to 12. If you want to actually do this, 1 to 2, 2, so it'd be 3, take 1 to 12. I don't want to do that in my head. So it'll be 1, I have a thing on my calculator. Why am I even trying? X, 1 to 12. That's 78. 75. There's your answer. What else is there? Dividing summations? Taking away series. That is literally it. It doesn't get worse than that until you get to limits, but I won't teach you limits. It's just basic summation.